Hello guys, welcome to IB360. So today we'll be solving the previous year questions of Neet. So this is the part 2 of the series of videos of previous year question of work, power, energy. So do watch the first part also. So let's get started. So hello guys, proceeding on to the first question. A vertical spring with a force constant K is fixed on a table. A ball of mass M at a height h above the free end of the spring falls vertically. So the ball of mass M is height h above the free end of the spring. That you have to keep this sentence in mind, okay? And the ball falls vertically on the spring so that the spring is compressed by a distance d. And the spring is actually being compressed by a distance d. So we need to find the total work done in this process. Okay, so first of all, this came in Neet 2007, and in order to solve this kind of questions, it is very much important that you draw a Neat diagram and try to understand what is going on. So I have drawn the diagram for you. Let us see how can you solve this question. So over here you can easily see that initially, so see, this is the spring, okay, this is the spring and this is the top end of the spring. So initially the ball of mass M was height h above the top end of the spring, right? So this is the top end. The ball is actually at a height h above the top end of the spring, okay? So now the ball is actually falling, okay, and it compressed the spring up to a distance a, right? So that means over here, see, this was the top end of the spring, right? And finally the top end of the spring got compressed by a distance a, right? So we need to find the net work done, okay? So that means over here the net work done will be the work done by the gravity plus the work done by the spring. Over here the ball of mass M is actually falling a distance of h plus a, okay? So that means it is falling a total distance of h plus a, okay? So that means the work done by the gravity on the ball of mass M will be mg h plus a, right? And we know that the work done by the spring is nothing but minus of half k delta x whole square, where delta x is the distance by which the spring is getting compressed or extended. Over here the spring is actually getting compressed by a distance of small a, right? So that means over here delta x will be our a. So that means over here the work done by the net work done. So over here the net work done will be mg h plus a minus of half k a square. So over here I did a teeny tiny mistake. So over here they are saying that the spring is compressed by a distance d, right? And I took the distance to be a. So nothing but a is nothing but d, right? So that means the net work done will be mg h plus d minus of half k d square. So that means the correct option to this question will be option number 1. So I hope you got this question. It's a good question. It can get repeated. So understand the concept, draw the diagram well, and you can easily solve this kind of question. So proceeding on to the next question. The force F on a particle moving in a straight line varies with distance d as shown in the figure. So we need to find the work done during its displacement of 12 meter. So that means it's again a very simple question. So it's from Neet 2011. So these kind of questions do come in the exam. You need to be aware of the concepts that are asked in the question. So let us see how can you solve this question. So over here we have discussed in the previous video also that work done is nothing but the area under force displacement graph. Area under force displacement graph. So over here you can see that on y-axis they have plotted force and on x-axis they have plotted displacement, right? So that means the area of this graph, so that means the area under this graph will give you the total work done, right? And we have to find the total work done up till 12 meter. So that means we have to find the area until 12 meter, okay? So that means what will be the area up to 12 meter? So this will be the area under the curve up to 12 meter, right? So that means over here you can see that you can divide this area into two areas, one rectangle, this one, and one triangle, this one, right? So that means what will be the area of the rectangle? Area of the base of the rectangle is spanning from 3 to 7. So that means base is 4, right? And the height of the rectangle is from 0 to 2. So that means height is 2, right, plus. Now what is the area of this triangle, right? What is the area of a triangle? Half into base into height, right? So the base is spanning from 7 to 12, right? So that means the base is of 5 units, right? And the height is spanning from 0 to 2, so height is 2 units. So that means half into base is 5 into height is 2. So that means this will be the total area under the graph. So over here the net area becomes 8 plus 5, so that means 13 joule. So that means the work done by the particle up to 12 meter displacement will be 13 joule. So the correct option to this question will be option number D, 13 joule. So it's a very easy question. You can easily solve this kind of questions in the examination. Uniform force of 3I plus J Newton acts on a particle of mass 2 kg. The particle is displaced from the position 2I cap plus k cap meter to position 4I cap plus 3J minus k cap meter. So we need to find the work done by the force on the particle. So it's a very simple question. It was asked in Neet 2013. So over here we can represent work done as, work done is nothing but F vector dot S vector, where F vector is the force vector and S vector is the displacement vector. Now over here the force vector is given in the question, and the force vector is 3I plus J. Okay, and the particle is actually displaced from 2I cap plus k cap meter to 4I cap plus 3J minus k cap meter. So that means displacement will be the final position vector minus the initial position vector, right? So what is the final position vector? Final position vector is nothing but 4I cap plus 3J cap minus of k cap, right? And the initial position vector is given in the question to be, so minus, initial position vector is given in the question to be 2I cap plus k cap, right? So that means minus of, so over here this will be 2I cap plus k cap. So over here if you solve this, we will get that displacement vector comes out to be 2I cap plus 3J cap minus 2k cap. So that means we have got force vector and we have got displacement vector, right? So that means what will be the work done? So that means work done will be F dot S, right? So that means this will be 3I cap plus J cap dot 2I cap plus 3J cap minus of 2k cap, right? Now if you take the dot product, so this will be 6 plus 3, so that means this will be 9. Okay, I am assuming that you know dot product. Okay, so over here the work done will be 9. So that means the correct option to this question will be option number D, 9 joule. It's a very easy question. You can easily tackle this, and this kind of questions do get repeated. So please take a note on this kind of questions also. So proceeding on to the next question, a body of mass 3 kg is under a constant force which causes a displacement S in meters. S is given as 1 by 3 t square, where t is in seconds. So we need to find the work done by the force in 2 seconds. Okay, so that means over here displacement is given as 1 by 3 t square. Okay, so that means what will be the velocity of the particle? It is nothing but the rate of change of displacement with respect to time, so that is ds by dt. So that means this will be 2 by 3 t. Right? Now what will be the acceleration of the particle? Acceleration is nothing but the rate of change of velocity, right? So that means dv by dt. So that means we find that the acceleration of the particle is constant and it is nothing but 2 by 3 meter per second square. Okay, so we need to find the work done by the force in 2 seconds. Okay, so that means work done. So over here work done by the force will be nothing but force into displacement. Right? So over here the force can be written as mass into acceleration, right? Mass into acceleration into displacement. So over here what is the mass of the body? The mass of the body is given to be 3 kg, right? 3. Now what is the acceleration of the body? Constant acceleration, that is 2 by 3 meter per second square into displacement. Now over here we need to find the work done in 2 seconds, right? So that means we have to find the displacement in 2 seconds. So over here the displacement is given as 1 by 3 t square, right? So that means see, at t equal to 0 our displacement was 0, right? And at t equal to 2 seconds our displacement is what? 1 by 3 into 2 square, right? So that means 4 by 3. right? So that means the displacement will be 4 by 3. So that means if you just solve this, the work done by the force comes out to be 8 by 3. So the correct option to this question will be option number 2, 8 by 3 joules. So it's a easy question. You can easily tackle these kinds of questions. So